Chapter 3 Review Rational Functions. Good luck with your studying. This is the second video for your review. It's reciprocal of a quadratic, and we'll be looking at questions 4 through 7. Just identifying what these are. Your reciprocal of quadratic could look like these three graphs. This first graph has one asymptote, and therefore would have an equation that would look something like this. 1 over, and then x minus whatever the asymptote is, so in this case looks like 2, and because it's a quadratic it's squared, so like a double root of 2, so our asymptote is at 2. That's what that one might look like. The second one has 3 branches to the graph, so this has this left branch, the middle branch, and the second branch, separated by 2 asymptotes, one at x equals 2 and one at x equals negative 3. So I might write this equation as 1 over x, and now using the asymptotes, x minus 2 and x plus 3. Finally, the last picture is the one with the bump, and it actually doesn't have the quadratic associated with it, doesn't have any real roots. So it would look like x squared. In this case, I'm going to say plus 1. So 1 over x squared plus 1. When I say no real roots, it means that this bottom part, you'll end up with a negative under the square root sign, and therefore there are no real roots. This particular equation is like the graph with the 3 branches. So if we were to quickly think about what the sketch might look like, it's going to have an asymptote at x equals 3. It's going to have an asymptote at x equals negative 4. And then it'll have the left branch, the right branch, and the middle part. So if I were to draw it, it might look something like this, just as a sketch, and then the middle part. To figure out where it crosses right here, we would just put in x equals 0. So that would be 1 over negative 12. So this actually would be a y-intercept of negative 1/12. So what I really need to do is determine my vertical asymptotes. So I already talked about those. So my vertical asymptotes are whatever the denominator becomes 0. So x equals 3 or x equals negative 4. Those are my 2 vertical asymptotes. My domain is totally dependent on those asymptotes. So we know that x cannot equal 3 because the function never crosses there, and x cannot equal negative 4 for the function. And then, of course, x belongs to the real numbers. That's our domain. Good luck. This quadratic has a double root. This double root is at negative 3. So then our asymptote would be at negative 3. And so that would be one of those, the graph that has just 2 branches to it, coming to a meet at the asymptote. So sketching it out, I have a asymptote at negative 3, and then I know that they're going to come together. Normally I would say they would come together like this, but because of this negative here, they're actually going to flip and they'll be coming together at the bottom. So I'm just going to try a different color here in green. So they're actually coming together at the bottom. Now, as for the y-intercept, or where it crosses the y-axis, again, we're just going to put 0 into here. So if you put a 0 right into here where the x is, you get 3 squared, which is 9. So that y-intercept is equal to negative 2 over 3 squared, which is 9. So negative 2/9 will be that particular y-intercept. The domain for this function will be all the possible x values. So our x values run from negative infinity to positive infinity, but do not include negative 3. So I would just write x cannot be negative 3, and x belongs to R. That is the domain. To find the asymptotes, I need to factor the bottom. Now that I factor the bottom, I can state the asymptotes. So we have vertical asymptotes at x equals negative 5 and x equals negative 1. Our horizontal asymptote, we have to consider what happens as x gets very large. As x gets very large in this particular equation, the bottom gets very large, so we end up with y going to 0. So y equals 0 is the asymptote for the horizontal asymptote. Our y-intercept, we're going to let x equals 0, and if we do that in this equation, we get 0 plus 5 is 5, 0 plus 1 is 1, 5 times 1 is 5. So my y-intercept then would be 1 over 5. The domain includes all values of x except for the asymptotes, so my domain is x belongs to R, x cannot be -5, and it cannot be -1. Our range would be all of our y values, which y belongs to R, and we'll say y cannot equal 0 because of that asymptote. As far as sketching it, we have an asymptote at -5, we have an asymptote at -1, the y equals 0 asymptote, and then we're going to go through a y-intercept of 1/5, so it's just a little bit above, and this is a 3-part parabola, so we know, or 3-part reciprocal of a quadratic, and it's positive, so it's going to come over here from here, go through that y-intercept, it's going to be upside down in the middle, and then it's going to be same thing over here, like a reflection. There we go. In number 7, you've been given information. You've been told that the horizontal asymptote is y equals 0. The vertical asymptote is x equals -4 and x equals 5. And the behavior before -4 is and after 5 is below 0. So the function will be below 0 in this area. So I'm going to start with the equation, or try. So f at x equals, and I know those vertical asymptotes will give me the factors on the bottom. So I'm going to write x plus 4 and x minus 5. The horizontal asymptote is y equals 0, so I know that it's probably a constant on top, but I need, I think I'll just put 1 actually. Now the next thing I need to know is think about the general behavior of this particular function. So if I were to sketch this, it would have an asymptote at -4, an asymptote at 5, and then this function that I'm doing right here would come up this way, and then upside down here. Now I want to check if this last condition is true for what I've just drawn. So when x is less than 4, less than -4, which is over here, I want y to be less than 0. So that's actually not true because y is greater than 0 right here. So I need this to be down here. And I'm going to check now the x is greater than 5. So x is greater than 5, I want it to be down here as well. So then that means we want the flip of this particular function. So the function we want is f at x equals -1 over x plus 4 times x plus 5.